from the left side, you've got C, and from the right side, you've got B. So whenever you have a limit as x approaches A, it means from both sides. So you can't call it like BC or CB. Like it. So it can't be both. So if they don't match, then the limit does not exist. Okay. So what is our limit as x approaches A from the left of f of x for the second graph? What about the limit from the right? What about the limit from both sides? B. Okay? Alright. So this time, your limit from the left and your limit from the right met at the same spot. So if this happens, it doesn't matter because limits, I'm not making it up. I promise. So, and with limits, you're not actually at A, you're approaching A. So as you get closer and closer and closer, what value to get closer and closer and closer to? You might not ever get there. Like they may not actually meet exactly, but it would be B here. So notice this little bullet right here. It says the actual value of the function, which is your f of A here, at a given point does not have to match the limit. So if you have an open circle, you can still have a limit. You can even still have a limit like, let's say the function had, let's say it had a dot right here. What would f of A be if we had a dot right there? 0, right? So the limit and the actual value of the function, they don't have to match. It's just from either side you have to have that same limit. Okay? All right, let's look at, which I probably shouldn't have wrote there because it's going to happen here. All right, so let's look at this scenario. What is our limit of f of x as x approaches P? R. Because P is right here, right? And as we approach from the left, and as we approach from the right, we're getting closer and closer to R, even though we don't actually get there because there's a hole in the ground. What? All limit values should come from the y-axis. Just like in our warm-up. All the limit values should come from the y-axis. Yes. Okay? What is f of P? Okay? You have a closed circle up here, so it is Q. It is okay that these don't match. Your limit can still exist. So you have a limit if you have a solid line or if you have a hole in the graph. But if you have a jump in the graph, the limit is not going to exist at that point, or not from both sides. Okay, questions? All right, let's try this one. I'm going to put a dotted line here. All right, this one's starting at f of A. Let's see. Eli, what is it? It is 0. When you're looking for f of A, you're looking for the closed-in circle, which has a y value of 0 here. Make sure your answers are always coming from that y-axis. So G, F, 0, and E are our only possibilities for answers here. They're not going to be A, B, C, or D, because those are from the x-axis. Okay? What is f of B? What do you think? It is undefined. And I like that Ethan said undefined, does not exist, because we're... All right, let's see. Logan, what about f of 0? G. Good. So we're looking at closed-in dots whenever it's asking us for the value of the function. All right, so let's see. Addison, what about number 4? What's the limit as x approaches 0 of f of x? It is f. Because from both sides, they meet right there at f. It doesn't matter that the colored in dots up here. They're approaching f even though they don't actually get there. Plus means right. From the right. Yes. So if it says from the right, you're starting over here on the right and you're going towards the negative. Okay. So let's see, Daniel. Number 5. Limit as x approaches a from the right. Number 5. Your left hand makes an L. It's important to know. It's F. It's F. I didn't hear your answer when I was saying that. You were just taking a while, so I was going to make sure you know your left from your right. Okay, so you're starting over here on the right side. You're tracing. You got an asymptote here, but you're tracing, and then it goes to this point, right? So it doesn't matter that it's an open circle. It's whatever you're approaching from that side. And so this y value here is f. So f is correct. It's not undefined. I mean, you're close, but you're using improper terminology. All right, hold on. Everybody quiet so I can hear Thomas's question again. Say it again, Thomas. Yes. So what's happening is you're going, like, you're starting over here, and you go up the hill, and then back down, and up here, and then, well, I guess technically, you jump over the asymptote, you come back down here, and you're approaching. You really don't have to start all the way over here. You could start right here, right side of that orange dotted line. And then it goes right here. And then so once you get to that point from that right side, you're looking over here to whatever the y coordinate is, which it tells us is f. All right, I didn't ask you this one, but let me ask you this one, Thomas. Well, I'm going to ask you another question. The limit as x approaches a from the left of f of x. I didn't put that as a problem on here. It's not going to be a, that's on the x-axis. It's going to be 0 because this point right here, the y coordinate for that point is 0. So that would be 0. So if the limit from the right is f and the limit from the left is 0, what is number 6? The limit from both sides does not exist. And I told Daniel no earlier because he said undefined. Undefined is for functions, does not exist for limits, although I realize he pretty much knew what he was talking about there, more or less. Okay, all right. Selena, what about 7? The limit as x approaches b of f of x. Okay, that's a perfectly acceptable answer. Or, since on this side, assume anything that looks like asymptote is. So, on this side, since they're both going to infinity, you could say positive infinity. So, either one. Okay, let's see. Noah, what about number 8? Limit as x approaches c. There's a 0. Maybe some zeros. All of these letters represent numbers, and we could put numbers here if we wanted. All right, Noah. C, limit as x approaches C of f of x. If it doesn't have a plus or a minus, it means both sides. Both sides. That's correct. Because on the right side, you go to this point. On the left side, you go to that same point. You've got a solid line right there, right? So it's just wherever it crosses the y coordinate there is 0. Very good. All right, and last one. Let's see. Emerson, sometimes I might need to move Emerson. I can't see him for damn well. What about D? The limit as x approaches D from the left of f of x. It is E. Very good. Okay, questions? Okay, you have I'm going to give you several different things. You've got a worksheet that has another example. I want you to try that one on your own. It's not homework. We're doing it right now in class. Yeah, we're going to have some delta math. Yes. Yeah. I think it's 30. You should be able to do these fast. Okay, do the other worksheet I gave you right now, though. We're doing that in class before we move on to delta math. Yes. Some of these might look like they sort of fall in between. Just go with what looks closest there. No. If you are looking like it's going to have to be a plus or minus, then that means it does not exist. Because from one side it's a positive number, from one side it's a negative, so they don't match.